In this video, I'm going to walk through some examples of association rule mining in Python using MLXtend or Machine Learning Extensions library. We'll be following the two examples in the association rules lecture slides. Links for the slides, the starter notebook used in this video, as well as the completed notebook for this demo are in the description below. So if you're ready, let's go ahead and get started. So here I have the association rules starter notebook open here. And the first step is we need to import the libraries that we'll be using during the demo. We'll be using the OS library as well as pandas, and then the MLXtend library with frequent patterns and pre-processing. So let's go ahead and run that. Example 1 from the lecture had an example with 10 transactions with various food items that were purchased in that transaction. This data has been saved to an Excel workbook named Association Rules Examples. This is in the data folder in the repository. If you go to the data, you can see your file here. So let's go back to our notebooks here. And so in this notebook, there'll be some example code that's already been provided, so I won't have to type that out. So here we're gonna create a data frame called ex1df. We're gonna use the pandas read Excel function. We're gonna use ospath.join. This will work on either Mac or Windows, so that's why I'm using that method here. We do need to tell Python to go back one folder and then go into the data folder and then refer to the association rules examples Excel workbook. The data is on the second sheet, so this is an index value. So index 1 will be the second sheet of the workbook. Let's go ahead and just display the whole output. Here we can see we have a tran ID that has been added as a column as well as the various food items. We really don't want the tran ID to be a column when we run the association rules. So let's go ahead and set that as the index of the data frame. Set index, we'll specify that we want to have the tran ID as the column, and we're going to do in place equals true, which will set the index directly in place in the variable in memory. Let's go ahead and run that. Next, the association rules in the MLXtend library, it does expect you to pass in Boolean values instead of integer values. You'll get warning messages if you pass in a data frame that's formatted in this way. So what we're gonna do is we're gonna go ahead and update this data frame, and we're gonna set all of the columns to bools. So we'll do ex1 df equals ex1 df as type bool with a default of 0, and then go ahead and display the output. And the notebook has expected output that with the code that's been previously run. So as you're working through the notebook and you write your own code, you could just verify that your output matches the expected output. Everything looks good here. So let's go ahead and move on to the next step, which we're going to display all frequent item sets that have at least a minimum support of 0.5. Here's the expected output. Let's go ahead and call this item sets, and we're going to reference the a priori function. We're going to pass in our data frame, ex1 underscore df. We're going to specify that the minimum support is going to be 0.5. We want the output to have the column names, so we're going to say equals true. Let's go ahead and just look at the entire output. You can see that the output is already the expected output, just not in the right order. This is a small transactional data set. Let's go ahead and sort it by the support column in descending order. So we use the sort values. We'll say by the support column, and then we'll say ascending equals false. Okay, so now we have the expected output, and our frequent item sets are saved in a variable called item sets. Let's go ahead and work through the next step to identify strong association rules with a minimum confidence of 0.5, and we're going to limit the output to just these columns, the antecedents, consequence, support, confidence, and lift columns. This code has already identified which columns we're going to include in output, and we're going to save those in a list called rule columns. So let's go ahead and create our rules. So rules equals, and we're going to reference the association rules function. We're going to pass in our item sets that we identified earlier. This is a newer parameter in the association rules. They do expect you to pass in the number of transactions that were in the original data set that you used to create item sets. So it's num item sets, and we'll just call that the length. We'll go ahead and reference this data frame here and get the length. The metric is going to be confidence, And then our minimum threshold will be 0.5. Go ahead and close that parentheses there. And let's just look at the entire output. So you can see that the association rules includes other metrics like the Jacquard similarity index. So this is why I identified just to select these 4 columns, because that's all we're interested in. So let's go ahead and select just those columns by referencing the rule columns. You can see that our output is also in a specific order. So let's go ahead and sort it by the lift first, and then we'll sort it by confidence. So do sort values by equals, and we're going to pass in a list here for our by. And we're going to say first by lift and then by confidence, close brackets here. And then we're going to say ascending equals false. And now we got our strong association rules. We used our frequent item sets of 0.5, and then we used those frequent item sets to identify our strong rules. In this particular case, the only rules were pizza and soda, or soda and pizza. When you purchase a soda with pizza, this does have the stronger confidence, so this occurred 100% of the time in all 5 transactions. However, when an individual buys a soda, they do not always buy a pizza. So the lift is the same, but the confidence is a little bit lower when you have the rules soda and pizza. So that wraps up example number 1. Let's go ahead and move to example number 2 from the lecture. This particular example, we used data set for purchases of different types of computer hardware, but I'm going to have this data set set up a little bit differently so you can see it in a different example. And here what we have is just an array data structure, or we have a list of lists where we have the different purchases in the list. So we're going to call this data set. Let's go ahead and create this variable. So we're going to take this data set in this list of lists, and we're going to transform it into a data frame of booleans for all of the different products that were purchased. So here, this is when we're going to be using the transaction encoder. So let's go to instantiate a transaction encoder here. Let's create an array, and we're going to use the transaction encoder. We're going to fit it to the data set that we just created above. Then we're going to transform it. Let's take a look to see what this outputs. So we essentially just take a list of lists with the actual product names, and we just transformed it into an array of booleans. But instead of passing in this to the association rules, we're going to pass in a data frame with the product names as the columns. Let's go ahead and create a new data frame. We'll call this ex2_df. We're going to call the pd.dataframe function. We're going to pass in our array. We're going to specify that the columns is going to come from the transaction encoder attribute. And here we're going to set right away into bools. And then let's go ahead and display the output. So we took that array and we transformed it into a data frame. So now we're ready to identify our frequent item sets. For this particular data set, we're going to specify the minimum support is 0.6. So you'll see that when we're working through association rules, the code will be very similar. And so what I'm going to do to save a little time is we're going to go ahead and just copy the code from example 1. We'll paste it here. We're not going to recycle our variables here, so we'll call this item sets 2. It's going to come from the ex2 data frame. Our minimum support here is 0.6. Change this reference to item sets 2. We're also going to sort it by support. And let's go ahead and run that. And you can see that that is our output that we're expecting. So we'll move on and select strong association rules. This time the minimum confidence is going to be 0.5. All right, let's go ahead and go up and copy what we did before to create our strong rules for example 1. You don't need to copy the rule columns again. Come down here. We'll go ahead and paste that here. We're not going to recycle our variables, so we'll call this rules 2. We pull this from item sets 2, and then we're going to reference EX2 data frame. It's still going to be our metric of confidence with a minimum threshold of 0.5. Let's go ahead and change this to rules 2. And then we're still going to sort by lift and confidence. Let's go ahead and run that. And there you go. All right, so now you have everything you need to work through problem 14.2 from the textbook. This is a problem where we're going to be using some data from statistics.com, so the Institute for Statistics Education. They offer different courses on statistics and analytics, and we're going to be using association rules to identify recommended purchases for users that have taken prior courses. You'll be using the course topics CSV file to work on this problem. So in this demonstration, I won't be working through the actual textbook problem. You could use the examples that were provided in this video to work through on your own time. Well, that wraps up this video on association rules. Reach out if you have any other questions.